Good day, everybody. This is Dr. Nandi. I'm back again to solve another problem in statistics. Please subscribe to my channel because I will help you to achieve your goal of success in statistics. Please hit the red subscribe button at the bottom right corner. Please subscribe to my channel. So without further ado, I'll get started. I'll share my computer screen with you. So this is a problem in sampling distribution, which is the probability distribution of sample means. So here is the problem. At an university, the mean age of students is 21.3 years with a standard deviation of 4 years. A random sample of 64 students is drawn from this population. What is the probability that the average age of the sample of 64 students is greater than 22 years? I'll first use the z-tables to solve this problem. By z-tables, I mean usually at the back of the textbook, statistics textbook, we have cumulative standard normal distribution area under the standard normal curve. That is the table I'm referring to. So first thing we have to remember, the mean of the sampling distribution is equal to mu x bar, because it's the probability distribution of the sample means are x bars. And that is equal to the mean of the population, which in this case is 21.3 years. Now the standard deviation of the sampling distribution. By sampling distribution, I mean the probability distribution of the sample means, is given by sigma x bar, which is sigma, which is the population standard deviation divided by square root of the sample size, or 4, in this case, population standard deviation divided by square root of 64, because my sample size is 64. Now square root of 64 is 8, so it's 4 over 8.5. Now we will calculate the z-score for 22 years, okay, for sample mean of 22 years. Remember, we are interested in finding the probability of x bar sample mean greater than 22. So let's calculate the z-score for the sample mean of 22, which is x bar minus mu divided by sigma x bar. So my x bar is 22 minus the mean is 21.3 divided by standard deviation of the sampling distribution sigma x bar, which is also sometimes called standard error, which is 0.5 in this case. So in this calculation, it works out z is 1.4. Now I can use this normal distribution table at the back of textbook, or we can find it on the web. So we want to find out the cumulative z-score up to 1.4. Now I have shown you the z distribution curve. Z equal to 0 is the center where the peak is the highest of the normal distribution. That is, the relative frequency is the highest. And cumulative area up to z equal to 1.4 means the area to the left of z equal to 1.4 under the standard normal curve. Remember, the standard normal curve has a mean of 0 and a standard deviation of 1. So we go to the table, look for z value of 1.4, and the first column after the z column is 0.00. That means the second place of decimal in this case is 0.00. So we will look for 1.4 and then 0.00. It is 0.9192. So the cumulative area, that is the area to the left of z equal to 1.4 under the standard normal curve, is 0.9192. So, but however, we are interested to find the probability of z greater than 1.4. So that is same as total area under the curve, standard normal curve is 1 minus probability of z less equal to 1.4. Which is 1 minus 0.9192, which is 0.0808. What is that number means? It means the probability that the sample mean of 64 students is greater than 22 years is 0.0808. Now let's do the same calculator using TI-84. That is, we do not use the table. Okay. Again, I show you the standard normal curve. The shaded area to the right of z equal to 1.4 is the area I want to find, which is the complement of the area to the left of z equal to 1.4. But when we use calculator, it is much simpler. We put our calculator on, then press the second key on the top left of the calculator, second key, okay? Say second key on the top left of the calculator, then verse key, which is in the third row. And then we scroll down to number 2, which is normal CDF. We always use the normal CDF key in this case, which is the cumulative distribution function. So I'm going to start from z equal to 1.4 because I want to find the area to the right of 1.4. I want to find the area greater than z equal to 1.4. So my lower boundary, that is under normal CDF, the first entry is lower boundary is 1.4. What is my upper boundary? It is all the way to the right, which is a very large number on the right, because remember the normal distribution curve is asymptotic to the horizontal axis. It never really touches the horizontal axis or cuts it. It comes very close, but never really touches it. So it extends up to a very large number on the right-hand side, which is exponent 99, means 1 followed by 99 zeros, which in this case will represent a very large number or infinity. So upper, what do? I first press number 1, then I press the second key, and then comma. You ask, where is comma? This is on top of 7 in TI-84. And that will give me the exponent e. And then I'll type the numbers 99. Remember, for a standard normal curve, mean is 0, standard deviation is 1. And I do not change those two values or parameters. And I go to paste and hit enter. So on my calculator screen, I'm getting this normal CDF, lower boundary is 1.4, upper boundary is a very large number, E99, mean is 0, standard deviation is 1. Everything separated by comma. And then I hit the enter button. And the answer is 0.08075, which is fairly close to what we got using the table of 0.0808. That is the probability of finding the mean age greater than 22 for a sample of 64 students for this normal distribution. So before I stop here today, I will remind you, please subscribe to my channel. Hit the Zoom button at the bottom right corner. Sorry, hit the subscribe button, red subscribe button at the right bottom corner of the screen. Okay. Why? Because I come back every week and solve new problems in statistics which help you to achieve your goals. So I'm there to help you to achieve success in statistics. Thanks for watching. Have a nice day. If you have any question, please do not forget to write a comment. Okay. I will get back to you. Okay. So thanks for watching. Have a nice day. Take care. Okay. See you next time.